Right, so now we'll look at the measures of dispersion. All right, so and the topic of describing data still. All right, so we'll look at the measures of dispersion. All right, what is actually measures of dispersion? Right, so the dispersion actually describes. All right, it describes. Let me highlight that one. It describes how data is scattered. How data is scattered. So the data is either widely scattered or just not really wide scattered, so it will be explained by the dispersion. And dispersion can also be meant by variation. All right, we can also check dispersion by we talk about variation, variability. They are all the same thing here. All right, so we should take note that if the larger the dispersion and then the wider the data is scattered, meaning that if we have the variable for the value for the dispersion which is large, and then it means that the data is widely scattered, right? And then we can also talk about the two data which having the same center value. It may have same center value. It could mean the median, mean, and mode, and so on, but it can have different variability, meaning that it can have this different scatter. All right, let's see this example to make it more clearer. We have A and B, right? You have data which the A is start from 30 and ends with 92, but the B is data from 60 and around 78. So they have the same mean, which is 68, but how the data is scattered. Okay, for the A data, all right, let me use the green color. For the data from A, it starts with 30, which is here, and it ends with 92, something here. All right, and it has 80, 85 somewhere around here, and they have the mean over here, something like that. But the data for the so for A, it is quite widely scattered there, but the A for the B, for the data for B, its minimum value is the 60, somewhere around here, and 70 is the maximum value, and mostly data is scattered around this value, so it is somewhere around here. So that's why this one is for A and this one is actually for B. All right, so they are scattered differently. All right, okay, so that's the overview of what dispersion is. So let's look at the dispersion of data. So it can be measured using 5 elements here. The first one is the range, where the range is given by the maximum value. If you have the maximum value, you have to subtract the minimum value. All right, so maximum value subtract minimum value, you get the range. And then you get interquartile range. So interquartile range is given by the formula Q3 minus Q1. All right, and then you have quartile deviation, which is QD. It's actually Q3 minus Q1 divided by 2. Or maybe you can take IQR, interquartile range, divide by 2. And then you have standard deviation, also variance, where the formula for standard deviation is given by square root of 1 over n minus 1 of in the bracket of summation of x square minus summation of x in the bracket square over n. And to find the variance, just take the square of this one, meaning that you have to remove the square root. Okay, so these are the 5 elements. When the question asks you to find the dispersions, meaning that you have to find these 5 elements here, 5 main things here. So let's we can divide these measures of dispersion into 3 types. The first one is the ungrouped data, the second one is ungrouped data with frequency, and the third one is the group data. So let's have a look at the first one. Right, if we have the ungrouped data, so we'll have to firstly look at the data, and usually we'll have to rearrange the data. So find the minimum value here is actually 6. All right, so you start with 6, rearrange please. All right, and then you have 7. After 7 you get, I think, 9. You have 9. After 9 you get 10. Okay, you get 10, and then still you get 10, another 10, and then you have 13, 13, and 13. All right, you have 3. All right, 13. All right, 13, 13, and 13. Another one is a 14. All right, you have 14, and then you have 15, and then you have 16 and 17. All right, so let's check the number of data, the number of observation: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are n, which is 12 observations from this data. Okay, so to find the dispersion, okay, let's talk about the dispersion. So the first one, we talk about the range. So range is the maximum value you subtract with the minimum value. So the maximum is 17, you subtract with the minimum value is 6, so the range is 11. Number 2, you can find the interquartile range. So interquartile range is given by Q3 minus Q1, but you have to find Q3 and Q1. So how to find the Q2 and Q1? Using the first quartile and third quartile. So you'll have to recall how to find the first quartile and third quartile. Firstly, you have to find the position. Firstly, position of Q1 is given by n plus 1 divided by 2. In this case, 12 plus 1 divided by 2. You get something like 6.5. So where is, sorry, 12 plus 1, right? Sorry, divided by 4, okay? Divided by 4. 12 plus 1 divided by 4, you get 3.25. Sorry, that was my mistake. 3.25, okay? Meaning that your Q1 is at the third position. So look at the third position. So this is the third position, which is 9. And then you have to add with the 0.25 of the fourth position, which is 10. You minus the third position just now, which is 9. Okay, something like this. So you will have a 9.25. This one is for Q1. And then you will have to find for Q2, Q3. So position of Q3 is given by 3 of n plus 1 divided by 4. So 12 plus 1 divided by 4. You multiply that one. You get 9.75. So look at your ninth position. So ninth position should be somewhere around, okay, the first 1, 2, 3, 4, 5, 6, 7, 8, 9. So your ninth position is here. So you have Q3 is given by 14 plus, 0.75 of the 10th position. Then, the 10th position is 15. This one, minus 14, the ninth position, and then you'll get 14.75. okay, so this one is Q3. So you have Q1, Q3 and Q1, so you can subtract. So this one could mean 14.75 minus 9.25. so you should have, you press your calculator, minus 9.25, so you get 5.5 is the interquartile range. Okay, and then you can have the quartile deviation. Number 3 is quartile deviation, QD. So QD is given by Q3 minus Q1 over 2. You've already calculated the Q3 minus Q1, so 5.5 divided by 2. So you should have 2.75. Okay, 2.75. All right, we are done with these three elements. The next one is to find the variance and also standard deviation. All right, you can find the variance first. All right, so the formula, okay, number 4, we find the variance, right, which is given by s squared is the 1 over n minus 1. Okay, 1 over n minus 1 summation of x squared minus summation of x square over n, all right, where n is the number of observations. So you'll firstly have to find the summation of x square and summation of x. All right, so how to find this? All right, so look back at your data. Okay, let me zoom out this one. All right, so that's your data. So summation of x square, meaning that this should be 6 square plus 7 square plus 9 square plus 10 square plus 10 square, 13 square plus 13 square plus 13 square. Another one is 14 square, 15 square, 16 square, and also 17 square. So you should get, all right, press your calculator. All right, hold on while I'm pressing my calculator. 13, 13, 13, all right, 14 square plus 15 square plus 16 square plus 17 square. So you should get 1,839, all right? So that one is your summation of x squared. But the summation of x is given by 6 plus 7 plus 9 plus 10 plus 10 plus 13 plus 13 plus another 13 plus 14 plus 15, all right? And another one is 16 and 17. So use your calculator. So, 6, 7, 9, 10, 10, 13, 13, 13. 14, 15, 16, and 17. So you'll have 143. Right? This is given by the formula. Okay. So you insert into the formula. So s squared just now. Right? This is s squared is given by. All right. So 1 over n minus 1. This one 1 over n minus 1. And this is 12. So 1 over 12 minus 1. Summation. 12 minus 1. Okay, summation of x squared is given by this one, 1839 minus summation of x in the bracket square, meaning that 143 square over n is given by 12 just now. All right, so hold on. Press your calculator carefully. All right, 143 square over 12. All right, divided by, okay, you should get 12.265. All right, so this is your variance. So finding the standard deviation is easy. So standard deviation, so given by s, is the square root of variance, so square root of s squared. So the square root of 12.2652. all right, you just take square root from the value from your calculator just now. So just take it and you get 3.6 you'll get 3.5022, something like this. So this is your variance and standard deviation. Okay, so let's now try for the ungrouped data with the frequency. Okay, ungrouped data with frequency. I'm sorry about this one. Okay, all right, let's look at this example. All right, ungrouped data, it is still ungrouped data, but it has frequency now. All right, so to do this, we can find the firstly, number one is we can find the range. R is given by the maximum value. Do not look at the frequency, look at the number of computers as the data. 4 minus 0. 4 is the maximum value and the minimum value is 0, so 4 minus 0 is 4. Number 2, look at your what do we call interquartile range, which is given by Q3 minus Q1, so you'll have to find Q3 and Q1 first. So in this case, finding Q3 and Q1 first. So find the position of Q1. Alright, position Q1 is given by how many number of data? So you should add this up. So 6 plus 8 plus 10 plus 4 plus 2. So 30, you have 30 data. So 30 plus 1 divided by 4. So 31 divided by 4, you get 7.75. Where your data is 7.75. To do this, please find the cumulative frequency. Alright, build another table. So cumulative frequency, you start with 6, add with 8, so you get 14. 14 add with 10, you get 24. And then 24 plus 4, 28. And then 28, 30. So where is your 7.75? 7.75 is not in the 6, so it should be, alright, it's not here, so it should be inside here. So, but the value of Q is 1, alright? So it is actually given by the formula. Q1 is the 7th position is 1 and plus 0.75 of still 1 at the 8th position minus the 7th position is 1, so still 1. Alright, so the same goes to position of Q3. Alright, so position of Q3, you should have 3 and plus 1 divided by 4. So you insert n as 30, so you should get 3 multiplied by 7.75. 23.25. So you have to find where the 23.25 is located. It's inside this one. So the 23rd position is 2. Alright, so Q3 is given by 2 plus the 0.25 of the 24th position is 2 minus the 23rd position is 2. So you get 2. Alright, so your Q3 is 2 and Q1 is 1. So your interquartile range is 1. So number 3, you can find the quartile deviation. So quartile deviation is given by the IQR that we have calculated just now. Should divide by with 2. So 1 over 2, you get 0.5. So you're done with this one, okay? So what you should do next is to find the variance and standard deviation, alright? So variance, alright? In this case, the formula is a bit different, alright, a bit different. It's given by the 1 over n minus 1, alright, still n minus 1. So summation, just now is summation x square, but now because we have frequency, so summation of fx square. So it should minus the summation of fx in the bracket square over n. Okay, so meaning that you'll have to find the summation of fx square and summation of fx. Okay, so let's work on it first. So summation of fx square, meaning to say that you'll have to multiply like this. From this is f, this is x, and you take square on that. So you get something like 6, 0 square. Okay, and then you'll have the next one 8, and then you'll have multiply with 1 square, and then you'll have to add 8 with 1 square, and then you do the next one 10 with 2 square. All right, so f is the 10 and the square is the number of computers, 2 square. So you proceed, so you get 4 with 3 square plus 2 with the 4 square. Alright, so you can use your calculator. So you should get, alright, hold on, 4 plus 3 square plus 2, 4 square, something like 116. Alright, that one is summation of fx square. So the next one is to find the summation of fx. So summation of fx, you just multiply without the square. Alright, the same process as you did just now. It's just that you don't have square. So 6 multiplied by 0, 8 multiplied by 1, 10 multiplied by 2, and then 4 multiplied by 3, and 2 multiplied by 4. Alright, so proceed calculating that one. Plus 20 plus 12 plus 8. So you get 48. Okay, that one is summation of fx. So Now you have n is 30, so the number of data is 30, so insert into the formula, so this one firstly. So 1 over n is 30, 30 minus 1. Summation of fx square is given 116 minus summation of fx in the bracket square, meaning that's 48 square over n is given by 30. Okay, something like this. So calculating that one, you should get over 30. Alright, divided by 29. Okay. I guess 1.3517. Alright, that one is s squared. So to find the number 5 is a standard deviation. I make it as acronym as SD. So given by s is given by square root of variance is square root of 1.3517. Alright. So the standard deviation is given by 1.1626, something like this. Alright. Okay. So you can find easily the variance and standard deviation. Alright. And the last one is the group data, where you have something like this. Okay. So when you have this group data, alright, you will have to find a lot of things here. Alright. So firstly, find the lower boundary and also upper boundary. Another one you'll have to do is to find the midpoint. Alright. And also the cumulative frequency. Right, to build a new table, right? So in this case, your lower boundary for the first class is 29.5, and then you get 39.5. All right, let's make it bigger. Zoom it. Okay. All right, so we'll have 49.5, 59.5, 69.5. All right, this one 39.5, 49.5. 59.5, 69.5, and 79.5. The midpoint, you can add the lower boundary plus upper boundary, divide by 2, or you can take the lower limit or divide by upper limit, add with upper limit and then divide by 2. So up to you, you just choose anyone. So 34.5, 44.5, 54.5, all right, 64.5, 74.5. Okay, so the cumulative frequency is given by 25, all right, and then 25 plus 16 is 41, 41 plus 12 is, 53, okay, after the 53 you get 7 is 60, and then you get 65, and you'll have to find the spread of this one, meaning that this is 1 until 25, and then you'll have 26 until 41, and then 42 until 53, okay, and then you'll have 54 until 60, and you'll have 61 until 65, something like this. All right, so build this table first, and then only we can find the rest of the measures of dispersion. So for the first one, all right, we can find the range, which is given by, okay, all right, so the first one is the range. For this case, you should take the upper boundary of the last class, all right, and minus the lower boundary of the first class. So 79.5 minus 29.5. Okay, you should get 50 is the range. So number 2, you'll have IQR interquartile range. So Q3 minus Q1. So a lot of things need to be done here, meaning that you'll have to find the first quartile and the third quartile. So it's quite long here, but never mind, let's try. So position of Q1 is given by n divided by 4. So n is actually 65. So 65 divided by 4, you should get 16.25. So you'll have to find a class containing this 16.25. So it's actually the first class here. Okay, let me highlight that one because 16.25 is inside this. All right. So so the formula is given by the Q1 is given by L1. Alright, L1 is the lower limit, so of the class that we highlighted just now. So 29.5 plus n over 4. N over 4 is 65 over 4 minus, and the cumulative frequency before that one, meaning that we don't have the class before that one, so it should be 0, over the frequency of the class of that class itself is actually 25. Okay, so you'll have to multiply with the class size. Class size is given by the upper boundary minus lower boundary, so it's given by 10. Okay, so you'll have something like, okay, 29.5 plus 16.25 over 25 multiplied by 10, so you get 36. 36 is your Q1. Okay, 36 is your Q1. And then we'll have to find the Q2 position, Q3. Position of Q3 is given by 3n over 4, alright? So 3 multiplied by 65, 3 multiplied by 16.25. So you get 48.75. So look at your cumulative frequency column. So which one is 48.75? 48.75 is somewhere around here. Alright, so you'll have to highlight the whole row, okay? So that one is for the Q3. So formula is given by, the formula should be given by Q3 L3, which is the lower limit, lower boundary, so 49.5 plus, okay, that one is 3 multiplied by 65 over 4 multiply and minus the cumulative frequency B4 is 41, minus 41 over the frequency of the class, so 12, okay, multiplied by the class size is 10. So you should get, okay, let me calculate that one first. So 48.75 minus 41 divided by 12 multiplied by 10 plus 49.5. Okay, you get 55.96, right, I guess. Okay, so you'll have Q3 and Q1 here. So into the formula, 55.96 minus 36. Okay, you'll get 55.96 minus 36. You'll get 19.96. That one is your IQR. And your QD, all right, quartile deviation, is given by IQR divided by 2. So you should divide 19.96 by 2. Alright, so 19.96 divided by 2, you should get 9.98 is your quartile deviation. And the last part here that we need to find is the variance. Okay, number 4 is the variance. Okay, which is given by S squared. Alright, so the formula is given by 1 over n minus 1, given by summation of fx squared minus summation of fx in the bracket squared divided by n. However, we don't have a point of x here, so what we have is the midpoint, right? This is the interval, but we don't have a point because it's given in the form of interval, so we'll have to find a point. A point is given by midpoint, so that midpoint is considered inside the formula. So x is actually the midpoint, okay, or the midpoint there. Okay, so what you need to find first is to find the, you'll have to multiply the, let's make it work here, alright, summation of fx square, okay, the midpoint is given that, meaning that you'll have to multiply the, what we call the midpoint and also the frequency, multiply this one and this one, okay, but you have to square the midpoint. Okay, so you'll have 25 multiplied by, okay, you should write, okay, 25 multiplied by 34.5 square plus, all right, 16 multiplied by 44.5 square plus, and then you have 12 multiplied by 54.5 square plus 7 multiplied by 64.5 square. Another one is 5 multiplied by 74.5 square. Okay, so please multiply that one, 34.5 square plus 16, 44.5 square plus 12, 54.5 square plus 7, 64.5 square plus another 5, 74.5 square. Okay, so you should get, the number is quite big here, 153,956.25. I hope I didn't do any mistake in the calculation. Alright, let me check the calculation first. Yes, alright. So that one is your summation of fx squared. So you should find the summation of fx, meaning that this multiply the frequency with the midpoint. So you'll have to find the 25 multiplied by the 34.5 plus the 16 multiplied by 44.5, and then you'll have 12 multiplied by 54.5, and then you'll have 7 multiplied by 64.5, and another one is 5 multiplied by 74.5. So you should get, alright, let's work on it. So 25, 34.5 plus 16, 44.5 plus 12, 54.5 plus another one, 7, 64.5 plus 5, 74.5. Alright, so you get 2052.5. Okay, so you should have that one. So now you can insert into the formula. Alright, so note that n is 65, so 1 over 65 minus 1. Summation of fx squared is given by 153,956.25 minus that 3052.5 square over n is 65. Okay, something like this. So 153,956.25 minus 3052.5 square over 65. Okay, should divide 64, so you get something like 165.7212. So that one is your variance, and to find the standard deviation, all right, let's zoom in this one first. So standard deviation is given by S is square root of 165.7212. So it's given by 12.87, all right, 8733. Okay, so that's how you find the variance and standard deviation for the group data. Okay, so we have done with the three, with the three types of data. All right, so let me recall. All right, let me just recall that one. For the ungrouped data, so the first one for the ungrouped data, so the formula for S square is given by 1 over n minus 1 by the summation of x square over summation of summation of x in the bracket square over n. All right. If it is the ungrouped data with the frequency, so s square should be given by 1 over n minus 1. You should have the summation of fx square minus the summation of fx in the bracket square over n. All right. And the last one is the group data, so you should have this variance as the 1 over n minus 1, summation of fx square, but this x is the midpoint, minus summation of fx, the midpoint, over n and square that one. Okay, so that they are three different types of formula there. Okay, so the coefficient, and the last part of this topic is the coefficient of variation given by CV. So CV is given by s over x bar, meaning that the standard deviation, all right, the standard deviation over mean, x bar is mean multiplied by 100%. So we should note that if we have the smaller CV, we compare two set of data. If the data with the smaller CV, meaning that it is less dispersed, and if it is less dispersed, so it is more consistent, meaning that the smaller CV will have the more consistent data or less dispersed. All right, so let's have one example here. So given already mean and also standard deviation, so what we need to do is to calculate the CV. So for the first one, mean over standard deviation over mean. All right, you should take 8 over 60 multiplied by 100. So 8 over 60 multiplied by 100, so you should get, this one is given by 13.33%. all right, so for B, it's 7 over 60 multiplied by 100, so 7 over 60 multiplied by 100 should get 11.67%. so which one is more consistent? So the one with the smaller CV, so of course this one is smaller, so meaning that the data from set B is less dispersed and also the more consistent than the data from set A, right? So how to find the mean? So we have talked about the finding mean. How to find the standard deviation? Also, we have talked about the standard deviation. So use those formula and find the CV, meaning that the formula is given by the standard deviation divided by mean multiplied by 100%. So that's all from me. Thank you for watching.